You're live.
All set. I'm live. Y'all can see me on the internet. Oh man, this is amazing. Hey everybody, welcome to Commit Your Code conference. The first talk of the day is always the worst, right? So, put me first and get this. We'll get this party started. Hey, I don't mean to gloat, but I am a member of a very exclusive club. It's not the Finer Things Club. I'm a member of the I have accidentally spent way too much money on cloud club. Anyone else ever get an unexpected bill on your cloud compute? Azure, AWS, Google? No, just me? Couple? Yeah. Hey, should we play the game of the largest amount? All right, more than 10 grand? All right, so my highest is, what's your highest amount?
Closer to 15.
15? Okay, so mine was around 13, 14. Not for this talk, but yeah, that's a different talk later. The amount, well, let's say the amount of the mistake. Yeah. So we have a secret handshake that we do whenever this occurs. It's just, oh my gosh, where'd all my money go? And sometimes you can get forgiven, sometimes you don't. But yeah, I've always done this with client money, never with my own money, thank goodness, because it'd be a real pain in the butt for me. It's always with clients, and it's learning things the hard way. So hopefully for you all, you take some lessons from this and you don't make the same mistakes that I did. Let's talk about the story just going into this. I'm talking about serverless. I'm going to talk about Azure Functions in particular. And when we talk about serverless, and you hear people talk about serverless, it's generally as a very cheap thing. Like serverless is generally cheap. You can do a whole bunch of work, millions and millions of executions, and it's pennies to do these executions. So for a lot of different things that you would do in software, it's really cost effective to do serverless. Now I'm going to warn you all now, I have a very severe Azure bias. So I have used all the cloud platforms. I'm going to talk mainly about Azure because that's where a lot of my bread and butter is, but the lessons that we'll learn here today really apply to any cloud provider out there. So hi everybody. If we haven't met yet, my name's Kevin. I'm the Microsoft guy in the room, other than Mr. Tim Corey back there. I love my .NET, I love my Azure. I'm the current president of the .NET Foundation, Microsoft MVP, all that good stuff. I love my Microsoft. If you ever want to talk to me afterwards, please feel free to hit me up on Blue Sky, not X, or LinkedIn, or go to my website. So everything I'm talking to you today is about lessons I've learned as a consultant, and this lesson in particular is from actually very recently. So let's start the mistake. Where did it all begin? It began when I learned about Azure Functions. That's the very beginning. We had an application, and generally what we do is we would have our main website, and then we'd have stuff in the background, web jobs, things that happen in the background. And every application has this problem. There's a million different ways to solve it. I actually do a talk on how to solve this 10 different ways in .NET specifically. And I'm not doing that talk here, but one of the ways that we come to solve this problem is take the main background jobs out of our application. It shouldn't be hogging resources from your main web app. It should be all stuff happening in a different service, different host somewhere else. And when I learned about Azure Functions, I took a lot of stuff that we were doing in the background of our app services and we're moving them to Azure Functions, which is really cool because we just do function A, function B, and it would just run in its own very cost-effective little host. And I learned about Azure Functions. We moved a bunch of stuff to it. I think the bill was like 3 cents. I'm like, oh man, I have a hammer and everything is a nail. Like I just wanted to put everything in Azure Functions, and I did. Like we just started moving all kinds of crap to Azure Functions. That ultimately led me to my mistake. I have a couple goals I want to achieve with the couple minutes I have with you today. The big thing is I want to talk about the promise of serverless. Like it was the golden child. It's supposed to bring balance to the force.
Yes.
And maybe if you don't understand how serverless works, let's talk about that too. Just it's very easy conceptually. We're not going to go deep in the code or anything, but we'll talk about what serverless is. And then we'll discuss when does serverless when is it a good solution? And then when is it a bad solution, or not the most optimal solution? So if I can answer those questions for you, we'll be good. The promise of serverless. All right. When I first started seeing serverless come into the ecosystem, I was one of these people who would sit there and go, it's just someone else's servers. It's not actually serverless. There's still a server there. Anyone else like that? That's the wrong way of thinking. That's a poor way of thinking, because it's so much more than just someone else's servers. There's infrastructure changes, there's architectural changes, and it's when I kind of got my head around how serverless works fundamentally that I really come to love it, and it became a hammer in my toolbox. All right, let's just talk about traditional application hosting. You have a web app, it could be anything. It could be .NET Node, it could be Laravel, it could be blah, blah, blah. And your application does stuff. You have API calls, you have different functions. When you host this, usually you're putting it up on one of the hundreds of hosts that are available out there. And you're paying for some sort of reserved capacity just to have the app up and running at any time. So if your app is just doing nothing, which a lot of ours right out of the gate does nothing, you're paying for those resources. Awesome. Now, when your app is fully up to scale, you're getting millions of requests per second, like you're just kicking butt. Well, you're still paying for that capacity, and you might run up against just how much that one host can do. So what do you do when you need more capacity? Well, you scale up. So you don't have just one host, you have multiple hosts, and they're behind some sort of load balancer. Well, when this happens, and you're at crazy scale, you're paying even more amounts of money. Like, scaling costs money in general sense. So you just keep paying over and over again. Now, with functions, we're going to change that mindset a little bit. We don't have the traditional app host that we're used to. We're just deploying functions. A GET request for that, a queue processor for something else. We're just pushing individual functions. Now, behind the scenes, there is a host, there is a server, all that stuff's happening. But when nothing's happening on the server, your app's just sitting there dormant, and you're not paying for anything. It's just a fraction of a penny to just exist. But then when you get that crazy scale and the application is just going full blast, you're still just paying pennies because it's only running the individual functions. You're paying for just the function to execute. And this turns out to save you hundreds, if not thousands of dollars over the long run, because you're just deploying functions. You're not deploying entire applications. And you don't need reserved compute. You just use the compute at the time that you need it. So in general, this becomes a very cost-effective way to do a lot of different types of applications. So serverless, in a nutshell, just architecturally, two concepts. You have triggers, you have actions. So something triggers a function to get executed. If you built a web API, you understand this. I make an HTTP call, something executes. But there's other types of triggers in the various cloud providers. Now, again, I'm Azure biased. We have a thing called blobs. It's like S3. You're putting files into a file system on the cloud. When that happens in Azure Functions, we can sign up for a trigger. I have a new file in my file system. I have a file was deleted, a file was updated. I can get these triggers. I can go execute a function. I use a lot of queues. If something hits a queue, I get a queue trigger. So I can go take that item off the queue, process it, rinse, repeat. And then we have very simple like HTTP trigger for webhooks and just simple API calls. Again, just execute a function. In terms of every cloud provider, I'm just glossing the surface. Like there's, Azure has like a dozen or two different types of triggers that it supports out of the box. You can create your own custom triggers. Other cloud providers are the exact same way. Now, this is great fundamentally, but there's a time and place for serverless. And let's talk about where serverless works really well, and then we'll talk about how I actually made a mistake. So first, serverless is great when you have very short-lived execution life cycles for your functions. So The ideal serverless function runs within a second or two. Now, depending on the platform, depending on how you configured it, you can have functions that run up to 10 minutes. And actually, I have a lot of functions that run in simple consumption that can run for 8, 9 minutes, and they still cost pennies over a month. So it's not necessarily a hard, fast rule that they have to be quick, but it's usually better when they're fast methods that just iterate quickly. Because you're only paying for the execution time of that function. If it runs for 500 milliseconds, you're only paying for 500 milliseconds. If it runs for 10 minutes, you're paying for 10 minutes, but it's still pennies on the dollar. Yeah, up to 10 minutes. The biggest benefit for me with serverless was that I didn't have to write application ceremony. We've all gone through the exercise, file new, go to the command line, blah, 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 new, you create your templates. And all of our apps kind of start the same way. Maybe you start with a starter pack and you rip out all the crap you don't need, and then you start putting in the stuff you actually need. I don't like wiring up things like just basic web app crud. I don't like setting up queue listeners. I don't like listening to blob storage. I don't like listening to email services. I don't want to write all that stuff. I actually would wish someone would just tell me when something happened. And that's what Azure Functions does, or what serverless does. Tells you when an action occurs. It's a trigger. So when that happens, I just go write the code to handle the case there's something new in my queue. I also get the benefit of automatic retries. So your code is perfect, but other people's code isn't. So a lot of APIs fail for various reasons. Databases fail for various reasons. It'd be nice if something failed, if it would just try again automatically, and you didn't have to like capture the error and then keep track of how many times it's failed. Like retry code is hard, and a lot of us skip it. So wouldn't it be nice if the service would just do that for you automatically? And serverless does that in a lot of cases. Burstable scale. This is where I really come to love serverless. I do a talk called Annihilating Workloads, and it's about burstable scale, where my Azure functions could just sit there and do nothing, and all of a sudden, I start populating a queue with not hundreds, not thousands, but millions of entities that need processing. And that's not the type of thing I just want one little app to iterate through. I want cloud scale. Like that's what they promised me, was I would have this infinite container of servers to do my bidding. Burstable scale. I can go from 0 instances to 25 to 1,000 instances within seconds to just annihilate the workloads that I have. And it really is turning the knob all the way up to 11. And I have numerous cases where like this has been amazing. There are also cases where this is not optimal. Number one, not every service out there is cloud scale. So while I might be able to handle thousands and thousands of entities at any one time, let's say I have a queue, I pull something off a queue, it goes to the database, does a simple CRUD action. Rinse, repeat, takes 500 milliseconds. That works really well, one at a time. Now let's scale that out to, let's see, 1,000 instances, all trying to do 25 items on the queue at a time. So 25,000 entities at any one moment. A lot of databases can't handle that out of the box right now. You have to pay for it usually. So most relational databases all work that way. I've taken down Mongo databases, hosted Mongo databases numerous times because it's just connections. I've tried to use more resources than I was actually paying for. So, oh, I was on the wrong dot. So this is usually the limiting factor for us. We've had workloads where if we just left it alone, we take care of hours worth of work within seconds. But our database couldn't handle the connection load, and we weren't willing to pay for more database, or a bigger database, or a more performant database. Because that's where you really get into the tens of thousands of dollars, is a database that can handle cloud scale. A lot of APIs also have rate limiting built into them, We were learning this a couple of weeks ago with OpenAI. We were building some services on functions, and we were talking to OpenAI. We were hitting OpenAI rate limits. And it's like, all right, well, this is a problem. So we actually have to go into the configuration for our functions and say, don't scale so high. It's like only scale to a 5 and not a 25. So it really impacts.
Throttle you at that point, or they just don't talk back to you?
What, OpenAI?
Yeah, or it gives you an exception.
They throw an exception. Yeah, they'll usually throw a 429 rate limit. And if you have retry logic, it's really easy. You just go back in the queue and you try it again in a couple seconds. Yeah, it's not great when that happens. The other big thing in serverless is if you have high compute or high memory requirements. This is where my mistake occurred. So high memory requirement being, if I show you the picture from earlier of a simple Azure function, I can do millions of executions. It costs pennies to do that work. Now, this is consumption level pricing. This is what everyone talks about as this is the way of serverless. And this is great. But these little instances that you get are very compute restricted. They're also memory restricted. You can't do a lot in these functions because you're not supposed to. They're really just meant to go do a simple API call and return a response. We had to move the bunches of the Azure functions, and we were hitting memory limits. So we're getting out of memory errors. It was causing crashes in our system. I'm like, oh, all right, well, how do we fix this? How do we get a little bit more memory? And like everything in the cloud, you can pay money for it. So Azure Functions has a level called Premium, which is still consumption. You're still paying for the execution, but you get a little bit more reserved capacity. And they have different levels of this, EP1, EP2, EP3. And they have more memory, more compute, all that good stuff. So we ended up using EP2 for 7 gigs because we were doing a lot of stuff in memory. We needed the RAM. And at the calculator level, this isn't a big deal. Like one instance running at this is about $300 a month. I would gladly pay this any day of the week if this solves my problem. This is fine. But let's go back to how serverless works. A lot of what we're doing is producer-consumer pattern. So I have a queue. The queue has items in it, and our hosts take things off that queue to process them. Now, as your queue grows, we're producing more. It's called back pressure. And as that back pressure grows, the functions environment is going to detect that and go, oh, I really should give you more instances to handle that load. Azure's goal, or serverless's goal here, is just to get rid of that queue as quickly as possible. And all right, so it's going to keep iterating on creating these function hosts. And eventually, as more stuff grows, it's going to go up to whatever your limit is for instances. Now, the limit out of the box for a lot of this stuff is 25 instances. So that's what we were doing. We were putting stuff in the queue. It was processing that queue as quickly as possible. It got up to 25 instances at EP2. I shouldn't say EP2, not EP1. But there's a problem with this. Even though it annihilates the queue, the work gets done. It's great. But it costs a lot of money to run 25 instances for a month in Azure Functions and Compute. And this is where our $8,000 came from. And turns out, like, you see this, go, oh, that's a mistake. I could have solved this 300 different ways better. That would not have been $8,000. So at this point, we're basically just throwing money away on our application. So there are a lot of different ways to solve this problem. But if I had thought more about the workload that we were going to be doing in serverless, I probably wouldn't have solved this problem. The big conclusion you should take from this is serverless is a great solution to a lot of different types of problems. I still use it every day. I'm not trying to recommend that you don't use it. I do want you to avoid the everything is a nail problem. Like functions is my hammer. And I love using functions, but I don't use it for everything. And you shouldn't do that either. And the big takeaway from all this is you should really watch your bill. All the platforms have some sort of budget protection built into them. And my bias is showing Azure does this the best. Google does this the worst. If there's any Google people in here, I'm sorry, fix your problem. So yeah, check your bills, set out-of-pocket maxes so you don't go over a certain amount. Also look at cost analysis, where your money's going. And don't make the same mistake that I do. So thank you all for hanging out with me. I'll be out in the common area if you want to talk about any of this. And thank you. All right, cool. That was easy. Awesome. All right.
So next up, we have Jerry doing build your own AI assistant with JavaScript, LLMs, and RAG, R-A-G.
All right, let's stop sharing. All right. All right.
Hi, Jerry. You as well. Good.
All right.
All right, so I think
That's all yours. So I'm just gonna disconnect real fast. And I'll take my water bottle. That one has not been used.
so there should be a link. It was in the.
That was great, Kevin.
Thank you.
Yeah. I tried to get some pictures too. I think I put one up on Twitter already. but
Oh, awesome.
I'll tag you in the rest.
Sounds good.
But yeah, thank you for doing that. That's great.
Hey, Sarah.
Hello, how are you doing?
Good to see you.
Yeah, good to see you too. I wanted to come say hi and I got questions for you about your stuff.
All right. Well,
Yeah.
let's step outside, and I'm happy to answer any questions you have.
I just
Oh.
have an easy one for you. I need to do this. Do you have any like good
Any other invite to any other
out of the box, like
rooms? Okay, then you should be good. And we can verify that once he joins, I guess, but we'll be okay.
Okay. All right, and then I'll just need you to share your screen, and then here's the microphone as well. So this is how the online chat can hear you.
Okay.
So just go ahead and throw that microphone on, and then we'll get started at 10:30, so 3 minutes.
Got it. Thank you.
And what time do you want, like a time check? I give you like a wave or something.
5
5 minutes left.
Yeah.
Okay.
Okay. And so, were you here when this
Yeah. I know it's awful. I'm hoping to get a bit
Were you able to join StreamYard
I
and
did. I
let's see.
shared my screen too.
backstage? Okay, cool. So you were in track 3, day 1.
Yeah.
And
Track 2.
Yeah. Yeah, you too.
Okay, we have a small change. We're gonna have you go to this address for your StreamYard. So StreamYard.com/NW.
what's happening?
NWU
CM
Z 2E6T. Yes, sir. Cool. And then it should have you, go through the whole process again.
Okay.
And then if you want, you should be able to, because we have the stream coming through this camera and the microphone you're going to plug in,
Yeah.
you should be able to turn off your mic and stop video, I think is what we're doing. Cool. Sweet.
All right, and then share screen.
Yeah, and it's here now, so we should be good. Okay, sorry about that. Yeah, we accidentally started this. Wrong kid. That's fine. Okay, cool. And then, yeah, you should be good to go as soon as the mic is. Thank you so much.
I'm driving down before you get a launch license. Like, if a launch license. Monday and the launch license on 7. You just gotta take a break. Yeah, it's like, I have to go to Iowa. And then actually, it's gonna launch. I saw last time we hotel room. And then so I was down there 2 weeks ago. And I was like, all right, good to see you catch now. Oh, so you saw it most recently? Yeah, I was down there. So they did, if you can see it, it came back pretty close to shore.
Sharing your screen on StreamYard.
It just keeps going off. I don't know. It's flickering. Can I connect directly via HDMI?
I'm not sure because I know we need it to be able to connect to the camera.
The reentry, software. It's way louder than talking.
Okay.
Can you just check?
Yeah, while I'm working, I just have like,
It's not popping up.
super cool. And then like, the experience of government more because it's like kind of. Rabbit hole. There's a lot of really cool stuff about it. They talk about it in the news. And we got like.
So, I mentioned it's like.
It just keeps going on and off. I think that's the problem.
Okay. The microphone is connected to there.
Microphone is fine. I think the moment I connect this,
And
that's a
this is
problem.
the HDMI.
Yeah.
I just don't know what this plug is. We're having an issue where it keeps flickering it and it stops sharing the screen.
Should I just disconnect the HDMI
I
and
just
try?
didn't know what this dongle went to.
I think
so
that,
didn't
that's for
wanna-
this.
Oh, yeah, we don't need that. If you could just click from your laptop,
Okay.
that would make things simpler there.
Let's try this. Yeah, it's
That's
stable.
all we need, yeah.
Yeah, it's
Okay.
stable.
Yeah, this is more just if you don't have a.
And then
I'll
HDMI
just click over
connector.
here. That's fine.
if you could share your. Oh, there you go. Okay, now I see it here. Alright, we're ready to go.
Mhm.
So I'll give you a wait 5 minutes.
Okay, so we're good to start?
Yes.
Okay.
Thank you.
Good. I'll start. Okay. I'll start. Okay. Hey everyone. Thanks for taking time to attend my session. I'm going to talk about how you can build your own AI assistant using JavaScript and obviously with all the hot buzzwords thrown out there. Okay. And this session is from a web developer's perspective, and that web developer is nobody but me. I've been in the industry for some time. I've built web apps, both front end and back end. And when all this tech came onto the scene, it was a little overwhelming for me. So this is part of my journey, my learning, and I'm trying to make it as simple as for you guys to get started. So yeah, if you're wondering, that's me and my dog as imagine my mid-journey 2 years back. So I gave it a photo and said, okay, imagine me as a Pixar character, and that's the best it could do. So there you go. Couple of disclaimers, everything that I'm going to say is mine. And yes, I did use a little bit of AI help in the deck that I'm going to show you. So what to expect, we're going to take a look at what exactly is AI and how you can relate to it, trying to draw some parallel lines over there. We're going to look at what LLMs are, what vectors, what are RAGs, and we'll get started with that. Quick show of hands, how many of you here are technical? How many of you are non-technical here? I know it's a small crowd. Technical or non-technical? Technical, okay. And how many of you guys have worked with AI or LLM of some sort? Okay, still good. Wow, that's a huge crowd. Okay. So here is, as promised, the fully buzzword compliance slide that has all the hot keywords out there. So as promised. But the reason I showed you that slide is the very first time you got started with that, all those buzzwords, right? When you heard it for the first time, was it a little overwhelming for you? You're like, it's moving so fast, I'm not able to keep track of it, right? So at the end of the journey, you climb that steep hill, you go up, and you're very anxious. And after that, you just realize what it is, and then you are in a state of nirvana, a state of calm, right? So I hope, if you are at the bottom of the hill, still trying to figure out what this is, I hope by the end of the session, I get you to the point where you understand this to an extent where you are able to relate to it in a simpler way and not be afraid of it, afraid of it. Okay, so first thing we need to understand is there are two kinds of AI engineers out there. The first one are the AI architects. So these are the geeks, the real AI geeks out there who does data cleansing, data labeling. They work with the cutting edge ML algorithms and build your net new models. These are the guys who publish models every week on Hugging Face and make your life hell, right? But then there are the AI chefs. The AI chefs are those people who, okay, knows there is a consumer problem or a customer problem that needs to be solved, and they take a model and try to build a UI, a good backend, and build a whole experience around it. And they are the chefs. They build for the customer, right? And I fall in that category, right? I play around with a bunch of models and I try to figure out how can I use this model or how can I solve something for my customer using all these models out there and do a lot of R&D and go through that process. So part of this is also how I approach these problem statements. Okay. Now, before we go dive anything into AI, let's talk about HTTP APIs. All of us have worked with APIs. At least everyone knows what APIs are. They know that these are HTTP APIs that we talk about. These are your garden variety HTTP APIs, right? And I hope by the end of the session, W3C doesn't come up with a new HTTP method. They have the habit of doing that. So the question that I want to ask you is, how do you build your APIs, right? And again, the question that I really want you guys to think on is, do you really worry about how HTTP works at a protocol layer in the at the backend, or you just use a library like Express or Nest.js to build your protocol, right? Do you care, or when you start building your API, do you start by implementing the HTTP protocol or use a library, right? You really don't have to go into the fundamentals of HTTP protocol. A knowledge of an HTTP protocol is all you need to do this, because, hey, knowing HTTP 1.1 makes new connections for every API request, versus HTTP 2 or 3 can open a connection and send multiple requests, helps you build your apps better, helps you scale your apps better. That's the knowledge that you need. You need not worry about how HTTP connects to your OSI layer model and how packets are being sent out. You don't need that. You need to understand HTTP to a point. You need to understand the technology to a point where you can better understand and use it to solve your need. That's what we need to target. And that's where we are going to focus, right? We're not going to go into the core technology, but we're going to figure out how we can use all this totally buzzword compliant session to understand how we can use it to solve problems. So let's start. So let's look at how an AI works, right? And I'm guessing all of you would have used ChatGPT or Gemini or Claude at some point and ask it to, hey, tell me a joke. That's where you would probably start, right? So when you ask the model to tell you a joke, the model understands some things. It has some capability to process your request and give you a response. But then again, there are other queries where the model does not have access to that kind of data that you have. Like, show me my expense from the last night. The model does not know it because it's never trained on that. So it has to go look up a knowledge system in the backend, right? So that's the two-way a model is going to work, or an AI is going to work. And again, I should have started with this. I'm going to use the term AI and model and LLM interchangeably according to the context, but I'm hoping that you guys would be able to follow me. Let me just fix that slide. There you go. I fixed it. Okay. Replace AI with API. That's fundamentally how you build an API, right? You have an API where you send in a request and your API logic is able to crunch something and give you a response. Or when you want to call an API, that API can't provide you the data, it needs to do a lookup onto the database. Compare that to the previous one. Next one. It's the same, right? The AI is going to process something and give it to you. It's kind of like a black box, or it needs some external reference to help you out with that. So this is how we're going to approach the entire problem, okay? Let's look at what a model is now. Now we are getting into the meat of it, okay? And model is definitely not that model out there. So a model is nothing but a mathematical representation of the knowledge it understands, or a mathematical representation of the world according to the model. And what is this world according to the model? It's the information or the knowledge that it was trained on, right? Somebody somewhere, an AI architect somewhere, took a whole bunch of publicly available Reddit posts and said, here is everything that I know, I'm labeling it for you, this is your knowledge. And that's what a model is going to encompass. It's like a black box, right? You're going to ask it some question, it understands, it has a world view according to the knowledge and going to give you a response. And there are multiple models like that. Some models understand audio, some models understand video, some understand text, some understand language, natural language, or some of them understand many of this, and that's what is called as a multi-modal model, or MMM, or There you go, okay? So that's a model. But when you start dealing with model, you need to have a way of figuring out what is the right model for you. These are the two tools that I go to. Okay, I'm not talking about ChatGPT or Gemini because those are hosted models. We'll get to that in a bit. But if I'm going to use my own model, and if I want to host my own model, and if I want to use it, these are the two things that I first go to. LM Studio, because it's a graphical interface where you can take a model, it gives a nice chat interface, you can upload your private document and ask it questions, and it just pretty much runs in your machine. You're not going to send anything out on the internet, right? Ollama is a good system to use also. It's kind of like Docker where you do a pull and then you run and use it. It's very easy to use. The thing about LM Studio and Ollama is both of them gives you an API interface to hit and consume. And that API interface both of these give is pretty much similar to the API interface that OpenAI has published, right? How you interact with these models. So that's something that you could use. The next thing that you need to worry about are parameters, right? If you look at any model on Hugging Face and you look at the example that I have here is Llama 3.1. You can see yeah, there you go. This is it has variations of 8 billion parameters, 70 billion parameters, and 405 billion parameters. So think about parameters as the brain size, the number of neurons in the brain. It's like the difference between a lizard brain, a monkey brain, and a human's brain, right? The bigger the number of parameters, the more processing power it has, the more understanding or the more clarity it has in terms of answers or responses when you ask it something. If I have time, I'll show you how that works because I have a model that very confidently gives you the wrong answer all the time. Okay. So try to stick with models around the 1 to 2 billion parameter level. That fairly gives you an accurate answer. Anything below, it's bad. That's the example that I have. So
What about more?
you can go more. I'm getting to that. So does brain power mean more resources? Absolutely. So there are variations of these models. So when you, I don't know if you can see it, every model that you go and refer on Hugging Face, you look for this file called, and that's at least what I do, the safe tensor file. I treat the safe tensor file as the size of the brain. The lowest model here has a safe tensor file of close to 3 GB. The next one has 2 of those files, and the big one has multiple such files. So that brain is essentially what needs to be loaded onto the memory for the model to compute and understand everything. So if you don't have that many resources, that model is definitely going to take a lot of time to come up and start processing, etc. Right? So what does this all mean? Again, I have 2 decades of experience. When I came to understand this, I stopped complaining about Java application. If my Java application says it needs 16 cores and 8 GB of RAM or 32 GB of RAM, there you go, take it, run it. I have no problem with you because you run fast compared to this, right? Now, this is where the distinction between a CPU and a GPU comes in. The only difference you need to understand between a CPU and a GPU is a CPU does instructions sequentially, it does one after the other, but a GPU can do it in parallel. So a model runs much better in a GPU because fundamentally at the end of the day, it's a mathematical model and it's going to crunch, or it has the same equation with multiple inputs running the same thing in parallel. At the end of the day, it's going to look at those numbers and give you something. So GPUs are better if you are going with your private model setup compared to CPU. And there's a whole YouTube link that explains that. I have links to that. I'll share that with you guys. So we understood what are models, how much the brain power, the parameter size, and what is needed to run it yourself. The next thing you need to know about a model is its knowledge cutoff. So you look at the fact sheet and it tells you what's the cutoff date of the knowledge that model understands. Over here, the Llama 3.1, the cutoff date was December 2023. What happens if you ask it questions very recent, it will very confidently give you a wrong answer. Okay, that's what's going to happen. So the question then is, what if you want your LLM or your AI to work on your private data? Okay, like the question that I asked, how do I find my top 5 expenses from last night, right? So that's where RAGs comes in, or the retrieval augmented generation comes in. Before we go into RAG, you need to understand one more thing, embeddings, because this term will also keep coming into picture. think back about the earlier diagram I showed you regarding an API. An API, when it wants data, it goes to a database and picks data from there. That data is in plain text, English, or something that you need to understand, that the API or you can understand. But an AI, because it's a mathematical model, it does not understand clear text. It needs to make relationships out of the text in it. So embeddings are nothing but a way of representing plain text, language in this case, into a mathematical representation that has some relationship with words and other things. And you kind of put all these embeddings of different documents or different text into a space to create a vector space. And that vector space has is clustered in a way where that information is kept in the database with some clustering around some relationship. Okay, that's all you need to know, that embeddings are mathematical representation that creates vectors, and you have a vector space which are multiple vectors bunched together. And a vector database is nothing but something that helps you manage your vector information like a database, right? And you're definitely not going to do a select star from table here. You're going to query it with some parameter saying that, hey, give me data which is similar to what I'm trying to find out, right? You're doing a semantic search rather than a select star from whatever table. That's the difference here. Now, once you have your vector database, and I'll show you some code at the end, let's get back to what retrieval augmented generation or RAGs is. It's quite a mouthful, RAGs, okay? So under the hood, this is how a RAG works. You will ask, you have a question, you will go look up the data or do a semantic search from your vector database. You will get set of results because that's a response that you get, and that's the context. You take that context along with your prompt, which is what was my last or what were my top 5 spends from last night. Give it to the LLM, and LLM is going to take that context that we retrieved from the RAG, the vector database, question, process it, and give you a response. This is how you plug in your private data to it. And if you want to completely run it privately, you run your model on your laptop, machine, your server, wherever it is, host your own vector database, stuff works pretty much the same, right? That's all there is to it. Now let's talk about where ChatGPT, Gemini, Claude, and the likes of it comes in. I told you that running a good model is resource intensive. It takes a lot of computational power. It takes it takes a good machine to run it. These systems out there, they are multimodal. That means they understand text, images, voice, video, everything. This is like a pay-as-you-go model. They have APIs to which you can send your context as well as your prompt, and you pay as you consume the APIs, and then you can start using it. This is a good way to get started if you're trying to build a Hello World equivalent of a program to get started, or try out some POCs. But the moment you are trying to deal with enterprise level data where it could be secure and you don't want it to go out, then we are looking at a hosted model kind of situation. Okay, code time. I hope it's clear. So again, written in JavaScript. The reason I want to show it in JavaScript is, look, it's if you're new to it, it's a lot of await async calls. It's easy to plug this into your API call, wherein so what's happening on the screen there is you're setting a context saying that, hey, you are an assistant, you're a helpful assistant, and I want to know the capital of the country that I'm going to plug it in here. And I'm using a very small model here. And when you ask it, hey, what's the capital of Italy? It's going to give you a response. That's it. That's all it takes to run. And this pretty much comfortably runs on your machine. That's all it takes. And if I want to use it with a vector store, the stuff on the left-hand side is me creating a bunch of context and other things and initializing a vector store, which is in memory. And the stuff on the right-hand side is how do I add a document? That's the entire load the document into, embed it or convert it into a vector format and then add it to in-memory store. And the code over here is, hey, what's the available parking space? It does a query, it gets the response, which is here under docs, and then I pass it to my model and say, hey, I want to know what's the available parking space, summarize it, and here is the context to it, and it's going to give you the response. Okay. The model that I use here is a Llama 3.2. I think it's a 2 billion parameter one. Again, that runs on your machine. No worries on that. That's it. And before I jump into the code and show you some stuff that goof ups that models can do, that's a link. I've put the slides, the session notes, couple of cool links that you can look at, including the link to my repository over there where you can just take a look at, critique it. Don't comment on my code. It's a quick POC code, not production ready. Don't use it. Test it before you use it. Okay. How are we on time?
5 minutes.
5 minutes? Oh, we still have time to show the code. Not the code. Let me show you what I meant by the confidently giving you the wrong answer part. Okay, you guys can see? Okay. So the first one is, I'm going to ask it, what is the capital of Italy? Let's see. It says Rome. It says Florence. Very confident. Again, it's Rome. It's Rome. Okay, okay, there you go, Florence. Okay, that's the confidence level it has. And under the hood, it's running, I think it's running the smaller parameter. Yeah, it's running the 0.5 billion parameter, slightly smaller. It's a lizard brain that's running. It's very confident in its answer. It's not going to give you the right answers. But whereas if I use something like, see, if I have a Gemini model, yeah, if I ask Gemini, oops, nope, you're not going to find my API keys in the repository. Don't worry about that. That's going to give you a bit more confident answer, and it's going to be consistent because it understands, it has that context, right? So again, if I want, I can also show you LM Studio. That's also a neat tool that you could use. That's LM Studio. Neat way you can find out models that you can use. You can use the Llama instruct model, say load model, and then you get a chat interface where you can upload documents and talk to it. The good thing about LM Studio is that it always gives you the CPU utilization at the bottom. It tells you how much RAM CPU it's using, and the moment you know your laptop, fans kick in, this is the problem. Okay, so there you go. That's how you can get started with. That's all I have. I hope you took away something from here, and it's a little more easy for you guys. Thank you. Again, I'll be around for 2 days. Oh yeah, please go.
So Apple just released Mac Mini.
Yeah.
And it's a great computer. It's pretty budget. And have you heard about using them, but not one, but several of them, 2, 3 in a rack?
Yeah.
How you can use the models?
I've not looked into it. I've heard about it. Again, the way I give out feedback is I need to try it out because only then I'm confident. So I've read about it. I don't know how feasible it is. But I'm in the works of trying to build my PC box. It's very difficult because the last time I built a PC was 20 years back. It was very easy to pick up a motherboard, a GPU, etc. Now I'm looking into GPU specs and trying to figure out what is the GPU that I need, purely because I want to see what it takes to run your model privately and other things. Right now, whatever I do, it's on the cloud. Okay. Yep. Sure.
Like you mentioned, as you add more parameters, the hallucination effect reduces, right?
Yeah.
Like you just showed
Yeah.
Florence versus Rome. So how do we measure the accuracy? Let's say I'm trying different Hugging Face models. I want to balance between the cost and the accuracy. What metrics do you, because it's what I understand is mostly stochastic, right? It's not
Yeah. So that's why you don't put your model directly into production yet. You go through a phase of, in the industry, it's called MLOps, where you train it and you do it testing cycle, and then you figure out, okay, how confident it is. The problem with all of that is it's a very human intensive thing where you have to go through it and figure out. Don't ask it to predict things, because that's where it really starts hallucinating. But if you want to look at data and ask it to summarize, that's where it mostly gets it right. Okay. Sure.
Yeah, so curious about showing when
Yeah.
hallucinating, have you seen the effects of using RAG on smaller models? Platform better?
Yes, the Quinn model, I used it in my example. I can change it to Llama, and if you ask it a question, it more often it tells, oh, I'm not able to find that context for you, or it's not going to give you a good enough answer, right? Let me see if I can, we're good on time?
There's not another speaker after you. We're going into open networking now.
Okay.
So I figured you can show some more stuff if people want to see it.
Okay, so this is the RAG model where I gave it a bank deposit letter, that's mine, to that, and I'm asking, hey, tell me more about the parking space, right? If I ask the same question to the Quinn model, which is a smaller model, it will not give me a good enough answer. Even the answer this model gives also is not great, right? So I was specifically looking for the information around the parking spot. This even ends by saying that there are two missing details, the parking space area, and that's a huge parking space. That's not the parking space. So even with a good model, that's the size of a house. So even with a good model, it's still not able to give a good enough answer. That's where you need a little more computational power to understand these things. And yeah.
So have you compared maybe like RAG as opposed to fine-tuning like smaller models in the performance background?
Not really, because when I want to use it for my private data, I'm piggybacking on Gemini, because my thought is, well, Google knows pretty much everything about me. What am I trying to hide from it by keeping my RAG private, right? I know. So I use the open Gemini API model, being very truthful here, and I use that to query my private documents. Okay. Okay. Cool. That's it. Thank you, guys. Thanks for your time.
And the data way, is that where? Is that what the data?
Yeah, it's something like splitting.
Okay, we're gonna walk around?
We have like. Let's say I can write it down.
Like, so much work on the library. And all the solutions that you have this really cool vector database.
That's where it takes a lot of
I
Agents that tell them, like, hey, there's a service out there that has this contract that can do this, and service out there that has this contract is and might choose to go to whatever you ask it to do. And where's your confidence level? But are you okay as long as it's like a get over type thing? Like if it's reading, that's fine. But I would trust something like that to do applications or posts that instantly. I mean, I've seen a lot. I've seen a lot of talks for some people.
Should we turn the mic up or so we can just battery?
Oh, yes.
Is there wireless mics?